much. So yes, welcome everyone, and thanks for joining this session. I'm going to start off by talking about climate change and health, and I'm going to try and focus a bit more on the urban environment. So as you're all aware, climate change presents many challenges to us all, and in particular, there's a global health risk from climate change. So this figure here summarizes the relationship between climate change and health. So our main driver of climate change is increased levels of greenhouse gases, such as carbon dioxide, which are mainly a result of human activity. And this leads to rising temperatures, rising sea levels, and other types of extreme weather events. And this kind of change to our climate then affects humans through a number of different exposure pathways. And some of these are more direct than others. So for example, extreme weather events and heat stress are kind of ways in which climate change directly impacts on health. But there are also less direct ways in which the climate will affect health through modifying things like air quality, food and water quality and supply, and also affecting things like vector distribution, so mosquitoes and disease vectors. And there are a number of social factors as well. So through these various exposure pathways, there's a result of different types of health impacts. And these can be mild health impacts all the way through to increased risk of mortality. And there may be physical or mental health impacts as well. But it's very important to realise that the extent of the risk and also the pattern of risk depends on a range of demographic and socioeconomic and environmental factors. So different climate change scenarios are likely to affect different populations very differently. And this is something that we need to take into account when we are looking at the impacts of climate change. So if we just start looking at temperature changes, since pre-industrial times, observations show that our temperature has risen on a global average by about 1 degree, and that's down to our burning of fossil fuels. So although it's 1 degree on average, if we look at a spatial view of changes in temperature, you can see that over the last century, most warming has taken place over land areas, and in fact it's rather higher than just a simple 1 degree uniform rise in temperature. So some parts of the world are experiencing temperatures more like up to 3 degrees. And obviously this has impacts on the population who live in these areas with rising temperatures. And it's possible to study the impact of temperature on mortality by investigating long time series of temperature data and comparing it with a daily mortality data, again over long periods. And in this way, you can use epidemiological analysis to link temperature and mortality. And just to give you a very simplified example, if we take a temperature distribution for a particular location, and that's associated with the same population group, you have a distribution of temperature which relates to a mortality risk. So below a certain cold temperature threshold, you tend to see rising mortality risk. And again, over a heat threshold, you get a rise in mortality risk as well. And for heat, this rise tends to be steeper than the rise for cold mortality. So due to the effects of climate change, we're likely to see increased temperatures. And it would be sensible to assume that a consequence of this will be that we'll see increased heat mortality and decreased cold mortality in future. Now, obviously, this is a simplified view of the modelling. It will give you an idea of how we come up with these figures, although there's quite a lot of assumptions made and also quite a lot of variation between different epidemiological models. But to give you an example of a study, this was a really huge study, the biggest of its type, looking at 450 locations around the world. And each of these spots represents a different location where the temperature and mortality relationships were derived. And then the idea was to project future temperature changes to see how heat and cold may change in the future. So the results of the study were broken down into 9 different global regions. So there are 9 panels here. For each of the regions, there's a low, a medium, and a high emissions scenario. The red lines show the change in heat mortality, and the blue lines show the change in cold mortality over future decades. And the results generally showed, on average, that there are increases in the future in temperature-related mortality. But it highlighted very importantly that there were lots of regional differences. And some of the regions which are likely to experience sharp increases in heat-related mortality in the future tend to be the regions that are already quite warm. So we've got Southeast Asia and Southern Europe and South America. So it's worth pointing out that most impacts like these can be avoided if we pursue active mitigation strategies. So for example, the Paris Agreement is to limit global average temperature to 1.5 degrees, or at the very most 2 degrees. And one example of using different climate scenarios shows you the impact of different emission scenarios. So this study was really very useful to highlight global disparity in heat and cold. And it was based on 5 global climate models as the input data. So for studies like this, there tend to be a number of assumptions and simplifications, which is standard practice. So things like local effects, like the urban heat island, are not included in here, and I'll revisit that in a minute. Also, the population was assumed to continue to be constant in the future, which is not likely to be the case, but it's often assumed to be constant because for the reason that we simply don't really know enough about how the future populations are likely to adapt to the effects of heat and cold. So I'll just introduce some similar work that we did specifically for the UK. And we wanted to look at how temperatures are going to change in the UK and how this will affect heat and cold mortality. And we used the UK Climate Impacts Programme projections. And these are a set of climate change projections which are tailored specifically for the UK, and they are delivered by the UK Met Office. So what we did was we derived temperature mortality relationships for each UK region, and there are 12 regions in the UK, and we also looked at separating by age group. We estimated the mortality due to heat and cold for a baseline decade, and then also used projections out to 2080. And in this case, we did include some projections of growth and ageing of the population, and that was from the Office for National Statistics. So the results are shown below, and the first thing that you can notice is that cold deaths are considerably higher than heat deaths. The scales on these charts are different. So we have more cold deaths in the UK than heat deaths. But you can also see that the projections are that we will see a sharp increase in heat deaths in future decades. And we don't really see a corresponding sharp decline in cold deaths, despite the fact that temperatures are rising. And one of the main reasons that we don't see this such a large drop-off in cold deaths is simply because we include growth and ageing of the population. And what happens in future decades is the UK population gets larger and more elderly, and therefore we have a much larger vulnerable population group. So this work told us that we already knew that cold deaths outnumber heat deaths, but this is still likely to be the case in future. We also showed that the effects of climate change on mortality are worse for older age groups, and we saw sharp increases in heat-related mortality in future, but less dramatic decreases in cold mortality. So this work was carried out with Public Health England when I was based at Public Health England. And we had to think quite carefully about the kind of messaging that we gave from this study, because quite often we would do a piece of work and it would get distilled down into maybe one or two sentences. So we thought quite hard, and the public health implications for this kind of work is that cold will continue to be a problem, and we certainly can't neglect the impacts of cold, particularly as we have our ageing population in the UK. However, we should focus increasing attention on heat-related impacts. And in the case of the UK, that's something that we're probably not as well adapted to, and we're not quite as prepared for as other countries that experience hot weather. I mentioned the urban heat island earlier on. So for those who are unfamiliar, local climate gets affected by urban areas. So it tends to lead to formation of heat islands. So the temperature profile over a city may look something like this, with the highest temperature in the city centre, and we get cold spots in parks and rural areas. And this effect, so the difference in temperature between the kind of hottest part and the rural area, can reach a maximum during hot weather. And that obviously has implications for overheating in cities. So I mentioned that we used the UK climate projections for our UK analysis, and these are at 25 kilometre resolution, which is actually quite high resolution for climate models. So global models tend to be much lower resolution than this. But you can see that even at 25 kilometres, you don't really see the impacts of urban areas throughout this map of the UK, because these kind of models are not really designed to pick up urban effects. However, we know that London looks a bit more like this, with this very clear heat island. We're also interested in urban areas because there's potential that urban populations are quite vulnerable to heat for a number of reasons. Also, over half the world now live in urban areas, and it's projected to carry on increasing in future. And in fact, in the UK, we are 82% urban at the last census count. So we are considerably more urban than the average. In many parts of the world, populations are growing and aging, and also urban areas are expanding. So there are a number of risk factors that we need to think about. I've talked about a shift in mean temperature, but climate change is also associated with increased risk of heat waves. So even though we may see small increases in mean temperature, so we shift a sort of old climate into a new climate, it means that what used to be considered very rare weather is now becoming really quite common hot weather. And we're also seeing these record-breaking hot temperature records. So I'm sure you've noticed over the last few years of record-breaking heat waves basically every year nowadays. And you can see that the shift in temperature from the 1950s to 2019 shows we're seeing decreasing levels of cold weather and much more heat. And when we tend to get heat wave events, although even moderate temperatures affect health, when you get a heat wave effect, it can be a really severe impact over a short space of time. And this can have impacts on health and social care systems. And to give you an example, this is some mortality data from France, and you can see 20 years of data plotted here. The red line shows the excess mortality for this year, and that's obviously reflects the COVID-19 outbreak. But if you look one of the background years is 2003, and you can see this really huge spike in mortality. And across Europe, there were up to 70,000 estimated deaths due to this heat wave. And in fact, in France, they were probably the worst country affected. They had 15 to 20,000 deaths, I believe, and really big problems for the medics and for the healthcare system. There's also a risk of compounding events. So air pollution is often exacerbated when we have heat waves. So looking at the 2003 event in London, we had a spike in temperature. We had about 2,000 excess deaths, well, over 2,000 in the UK, so spike in mortality. But at the same time, we also saw spikes in air pollution. So here is ozone and particulate matter. And it's reasonable to assume that a certain proportion of the heat deaths were also due to air pollution, or at least exacerbated by air pollution. So I'm just going to move on now to talk about how we are trying to model and understand some of these sort of uncertainties in urban environments. And we've been doing some regional meteorological model to look at the health impacts of the urban heat island. And our study area is the West Midlands. So this was work that we carried out in collaboration with the University of Birmingham. So that's why we were looking at this region. But the West Midlands is the second most densely populated region in the UK outside London, and it includes the cities of Birmingham, Coventry, Wolverhampton, and it's really very urbanised. So we use a model, a meteorological model at 1 kilometre resolution, and within the input to the model, we classify urban areas into different types of urban. So we have industrial, high intensity residential, low intensity residential areas. We have non-urban areas, which are further categorized into different types of rural kind of categories. And then even within the urban categorization, we have a surface urban physics scheme where we are able to look at the vertical distribution of things like heat and so on, and we can parameterize individual effects of buildings and so on. And the idea is to produce high resolution temperatures across our region. And in addition, we can also manipulate some of the building parameters within our building model to look at the potential effects of interventions in urban areas. So what we found from our modelling was that in our study area, you can see this is the average urban heat island across the region, but at its peak, we found that urban heat island intensity can reach 10 degrees for the West Midlands. And we further estimated that the urban heat island is responsible for around 40% of heat mortality, and that rises to about 50% during a heat wave. So we're also interested in potentially what we can do to mitigate this kind of heat. And what we did was we ran some simulations in our model where we implemented what's known as cool roofs. So these are roofs that are made of very highly reflective surfaces to reflect solar energy. And what we found was that we implemented them on the different types of urban categories, and we found that cool roofs were most effective on commercial buildings. And they're most effective at lowering maximum daytime temperatures, because obviously this is the time of day when we have the most sunlight, and they could be quite effective at reducing heat-related mortality as well. And we were also interested in looking at the co-location of risk factors. So obviously we have the highest temperatures in our built-up areas, and this coincides with high levels of population density, but we also see the highest levels of deprivation in these areas. And in fact, if you plot increasing deprivation with urban heat island intensity, you see this kind of increasing relationship here. And we found that housing types which are prone to overheating, like flats and apartments, they tend to be located in the warmest parts of the city. And that's also true for things like hospitals and care homes and nurseries as well. So these kind of places where vulnerable people may live or have to visit tend to be in sort of places that are subjected to high heat stress. So just to summarise, temperature changes are leading to increased mortality in many parts of the world, particularly in the warmest regions. Urban populations are likely to be at high risk of overheating due to the urban heat island effect. We need to explore quite a large range of complex risk factors in order to improve health estimates, to better assess the role of adaptation measures, to reduce multiple risk factors in future, and to properly target vulnerable populations. We're going to need to employ adaptation measures as well as mitigation measures in terms of climate change, because we're already locked into a certain amount of temperature rises in the future, and we're already seeing changes in temperature at current day levels. However, it's possible that we can achieve health benefits from policies aimed at mitigating climate change. So, for example, we may, if we reduce reliance on private vehicles, we can reduce greenhouse gas emissions, we can also improve local air quality, and then we can increase the levels of active travel like walking and cycling, can maybe increase amount of green space, which has health and well-being benefits, and mitigates against climate change as well. And I'm sure Mike will cover some of these kind of health benefits as well in his talk. So just like to say thank you for listening, and I'm happy to take questions afterwards. I'll stop sharing.